In this video we're going to do some problems on the introductory problem page, applying trigonometric functions 5.4 in our text. This first problem, number 49, deals with a seat on a Ferris wheel as it rotates around. So let's look at the problem. So Domingo decides to ride the Ferris wheel. The seat starts out being 4 feet above the ground, so this is 4 feet. The radius of the Ferris wheel is 36 feet. Which means that the diameter of the Ferris wheel is 72 feet total. And that's all for right now. So for part A, if the radius of the Ferris wheel is 36 feet, how far above the ground will Domingo be when his seat reaches the top? So when he reaches the top, he's actually up another 72 feet in addition to his original 4. So he's at 72 plus 4 makes 76 feet. For part B, the Ferris wheel rotates 300 degrees. So from this bottom seat, we have to apply a 300 degree rotation. So there's 90 degrees, there's 180 degrees, here's 270 degrees. It takes another 30 degrees to get to the 300 degrees. So the seat ends up there. And this problem is asking us how far above the ground is Domingo when the Ferris wheel stops. So let's draw the triangle that represents this. In relation to the center of the Ferris wheel, this 300 degree angle is 30 degrees past the horizontal, so that actually gives us a 30 degree reference angle for that triangle. The radius of the Ferris wheel is 36. So if I say draw the triangle out here to the side, we've got a hypotenuse of 36, we've got a 30 degree central angle, and we can actually solve for that opposite side using tangent. That will give us this piece right here, which is how far Domingo will be down from the center of the Ferris wheel. So once we get this number, we'll have to adjust it and see how that actually applies to him being up from the ground. So this is a tangent ratio. You've got, no, this is a sine ratio. Here's the hypotenuse. You have opposite over hypotenuse. So we can set up sine of 30 is equal to x over 36, which is opposite over adjacent. And so the 36 times the sine of 30 is going to be x. We could use a calculator on this, or we could use our special triangle ratios of a 30, 60, 90 triangle. And we have 1, radical 3, 2. So the sine of 30 is 1/2. Half of 36 is 18. So x is 18 feet. That means that from this center of the wheel, which starts out being 40 feet up, Domingo's seat is 18 feet below that. So if we do 40, take away 18, we end up at 20 2 feet. So for part B, Domingo is 22 feet above the ground when the Ferris wheel stops. So using this triangle, we did a 300-degree rotation in relation to the seat starting down here. This 300-degree rotation is actually 30 degrees past the 270, which gives us a 30-degree reference angle. We could do sine 30 times 36, which is 1/2 times 36, or use the special triangle ratios and get half of 36, which is 18 that way. This side of the triangle is 18. He's 18 feet down from the center. The center is actually up 36 plus 4, which is 40. 40 take away 18 is 22. For the next part, suppose the radius of the Ferris wheel is only 30 feet. How far above the ground is Domingo when the Ferris wheel stops at 300-degree rotation? So the only difference between C and B is the radius of the wheel. The radius goes from 36 down to 30. At 36, 18 was half of 36, which was how far the seat was down from the center. With a 30-foot radius, half of 30 is 15. It's going to be 15 feet down from the center. Now with a 30-foot wheel, the center of the wheel is going to be up 30 plus 4 because it's 4 feet off the ground. So 4 plus 30 makes 34, and 34 take away 14 leaves 20 feet. So with a 30-foot radius wheel at a 300-degree rotation, he's going to be 20 feet off the ground. Part D. Suppose the radius of the Ferris wheel is r. Write an expression for the distance from the ground to Domingo after the Ferris wheel rotates 300 degrees. So the radius of the wheel plus 4 gives the center. This is the radius plus 4 that gives the center. So we could write r plus 4, which is the center of the wheel, minus 1/2 the radius of the wheel is going to give us the height. So let's look at that, and this can be simplified. In general, the center of the wheel is 4 feet more than the radius. So the center is 4 feet more than the radius. We're subtracting half, which is the sine of 30, times the hypotenuse. The radius is the hypotenuse. So we're subtracting half the radius for this one, which is the 18. We're subtracting half the radius for this one. Okay, there might be a mistake on this one. We're subtracting half the radius of 30, which is 15. And the center was up 34. 34 take away 15 ends up being 19. So I think for number B, the answer should have been 19 feet. And let's see what else. So that would have been for this problem here. So 4 more than the radius is the center. The center take away half the radius is going to give the distance down from the center of the seat, and that should give us the height. Now we can maybe simplify that. Let's see, r plus 4 minus a half r. We get half r plus 4 equals the height. So 1r take away a half r, gives us a half r plus 4. So we can kind of check that out in general. If the radius was 36 feet, he's going to end up at half of 36, which is 18 plus 4, which gives the height. If the radius of the wheel is 30 feet, half of 30 is 15. 15 plus 4 gives us 19, which is the height that he is above the ground. So this is the simplified version that works for the general case, assuming that for each time we're doing the measurement, it's at a 300-degree rotation. Okay, let's look at 45. This equation, or relationship, gives us the time that it takes for a box to slide down an inclined plane based on the angle, and it's neglecting friction, and where a is the distance of the plane. But what they ask us for this is, for what values of theta is the expression undefined? So we have a fraction inside of this radical. Any place where we would have a 0 in the denominator is going to cause that fraction to be undefined. So, in other words, what we need to do is find the angles where sine of theta is equal to 0 or cosine theta is equal to 0. So if we go to, say, the unit circle and think about the angle, the quadrantal angles, out at 0 degrees, you have a 1, 0. Cosine is 1, sine is 0 of 0. At 90 degrees, we have a 0, 1. Cosine of 90 is 0, sine of 90 is 1. At 270 degrees, we have a negative 1, 0. Cosine is negative 1, and sine is 0. And at 270 degrees, we have a 0, 1, and 0, negative 1. The cosine of 270 is 0. The sine of 270 is negative 1. So we can use that to find the angles that match the situation. So where sine of theta is 0 is going to be at 0 degrees, and it's going to be at 180 degrees. Where cosine of 0 is 0 is going to be any place where the x's are 0. That's going to be at 90 degrees and at 270 degrees. So those are the angles where theta would give us a 0 in the denominator of that fraction inside the radical and would cause this to be undefined. Let's look at one on the other side now. One thing we need to make sure we keep track of is that a lot of times we'll be given measurements in degree, minute, seconds, and to use our calculator most efficiently, we want to change this into decimal degrees. So we have 52 and 15/60ths, which is 52.25. So be sure that we make any changes into decimal degrees. And this would be just a normal, looks like it's going to be a sine problem for R, and it's going to be a tangent problem to find D. But let's look at this surveying problem here. So there were two lines, two angles of elevation taken. The first angle of elevation was X feet away from the mountain, and the angle of elevation was 40 degrees and 30 minutes. Now 40 degrees 30 minutes is 40 and 30/60ths, which is 40.5 degrees. We might as well do this other one too. We've got 37/46. That's 37 and 46/60ths. And if we do 46 divided by 60, we get 7.6, so let's call it 0.77. So we get 37.77. Okay, so we've taken care of making the adjustment to decimal degrees. In a situation like this, you've got this larger triangle, and then you've got this smaller triangle. And what they both have in common is that this side H is the same. So the plan for a problem like this is to represent both triangles in terms of the trigonometry, solve each triangle for H, and then set the two triangles equal to each other. And that way we can find x. Once we do that, once we find x, we can plug it in to one of the equations, and then we can find h. So say doing the larger triangle, we've got this 37.77 degree angle. Let me draw it out here separately. So this angle is 37.77. H is the opposite side, and this adjacent side is 1,000 plus x. And we might as well draw the other triangle while we're at it. This other triangle has a 40.5 degree angle. This side is h, and this side is x. So we want to write a trig ratio that goes with each one of these situations. With the larger triangle, we've got an opposite over adjacent, that's a tangent. So tan 37.77 is equal to h over 1,000 plus x. And we need to get h by itself, so we're going to multiply both sides by the denominator here. So we have 1,000 plus x times tan 37.77 equals h. So we've got the larger triangle solved in terms of h. We want to do the same thing for the smaller triangle. Opposite over hypotenuse, or opposite over adjacent, we've got a tangent again. Tan 40.5 equals h over x. Multiply both sides by the x. X times the tangent of 40.5 equals h. So we've got the smaller triangle also solved in terms of h. Now since these two triangles both have h in common, which is the same number, we can set these two expressions equal to each other. So, and I'll go ahead and distribute when I do this. So I have 1,000 times the tangent of 37.77 plus x tan 37.77 equals x tan 40.5. So all I did there was use the idea that h in the larger triangle is the same as h in the smaller triangle. Okay, now we have to group like terms together. I can get all the x's on this side by subtracting x tan 37.77 from both sides, and we get 1,000 tan. I'm going to round this off to like 37.8. So 1,000 tan 37.8 is equal to x tan 40.5 minus x tan 37.8. These both have x in common, so I can distribute and take an x out of both of these. So I have x times the tangent of 40.5 minus tan 37.8 equals this other side. I might as well go ahead and turn this into a regular number now. 1,000 times the tangent of 37.8. 37.8 tangent equals, I get 775.7. We might as well go ahead and simplify this. So tan 40.5 tangent minus 37.8 tangent equals 0.078. So this is x times 0.078 when it's simplified. What I need to do is get x by itself. So I need to divide by 0.078. And x is going to be whatever 775.7 is divided by 0.78. So 775.7 divided by 0.078 comes out to be 9944.8. So let's call it 9945. So x is 9,945. We need to find out what h is, though. So if we go back to our original equations, we could plug x in here, or we could plug x in here. This would be the simplest one to plug x into. So I'm going to calculate 9945 times the tangent of 40.5, and that will give me the height that we're looking for. So we have the 9945 times 40.5, the tangent of that equals 8493.7, or 8494 feet equals the height. And that's how we find the height. So to recap, we've got two nested triangles. They both have h in common. We had to change to decimal degrees. We can find a tangent ratio representing the larger triangle, another tangent ratio representing the smaller triangle. We've got to get rid of this extra variable. So by setting them both, solving for h and setting them both equal to each other, we can solve for the x. Once we find the x, we can substitute into one of the original equations, and we can find out what the height is. Okay, that's it for this page. We've been going over this in the last couple of class meetings. So if you have any questions on this, let me know.